Because nothing gets you ready for a new term quite like bagpipes. Because nothing gets you ready for anything quite like bagpipes. So welcome to the first Java lecture for CS 141. This is John Dooley and Jamie Spacco trying to come up with kind of a single 141 that we can both teach, and then kind of like save on some of the work with all of the video production that we're doing. So what do we have on tap for today? What is Java? Your first Java programmer, and then a number of details about Java-related stuff, identifiers, string literals, escape sequences, things like that. So what is Java? It's a high-level programming language. The first thing students say when they start looking at Java code is, good grief, you call this high level? It looks very low level to me. But I assure you there are lower level languages. You can write things in assembly code, which is very low level. Below that you can do it in binary, which is even lower level. And then below that there's like, I don't know, voltage differences in energy and various other things that happen with hardware. I don't really understand that stuff. But basically you're able to write out sequences of commands for the computer to carry out. Oh, that reminds me, I need to tell you a joke. How many computer scientists does it take to screw in a light bulb? How the heck should I know? That's a hardware question. Ha! Get it? Because I mentioned there's hardware underneath stuff. Great. Moving on. Let's jump right in. Let me show you your first program in Java using a tool called BlueJ. BlueJ is the introductory editing environment. It's called an integrated development environment, or IDE. We have a separate set of videos specifically on BlueJ. So what I'm going to do is go ahead and show you this is the text of the program. We've got things in here. These are print statements. We're going to come over here. This program's called Hello World. I'm going to right-click it and run it. We'll see what it does. Oh my gosh, this is slow with QuickTime running. Let's see what we've got. And Shazam, look at that. It prints out a bunch of messages. Isn't that fantastic? The answer is yes, it's fantastic. So, I did this when I was first teaching introductory Java, back in the 2000s. I showed this little sample bit of code, that first line of BlueJ code we saw, print, system out, print line hello. And I asked the students, okay, what does this look like? Does this look like something else from another course? And some years I'd get the answer I was looking for, which was, yes, it looks like a mathematical function, f of x, where the function f is the print line function and the argument x is the hello part. So that's what it does, right? This part here is a command that says, hey, go ahead and print. And then this is what's going to be printed, and then you can see the parentheses here. So this is f, there's the parentheses, and the hello is x. That's the thing that's getting printed. So naively, this is what I was hoping, I would hear every year. And of course, that's not at all what happened. I had some fantastic answers. It's a random collection of letters that makes absolutely no sense, and man, I really wish it weren't too late for me to switch to biology. So that's one possible thing. The other thing, one student, a history student who was a senior, really needed a science. Like, that's ridiculous. But then I thought about it, and I'm like, well, no, that actually kind of makes sense if you think about it, because we've got periods being used clearly not to end a sentence, as they normally are in regular English grammar. We've got quotes, but they're not being used for, like, quoting something that a character in a novel's saying. They're being used for another purpose. We've got parentheses, but they're in another place. We've got the semicolon at the end. And if you think about bibliographic formats, those use punctuation, but they use punctuation in these very potentially odd ways, or non-standard ways. And so actually I thought that was a really profound observation that student made. We're treating all of this stuff in here as symbols. So this is actually not always a trivial thing to do if you don't realize you need to do it ahead of time. You have to unlearn whatever you've learned about grammar. Semicolons are now going to end statements. Periods are going to be used in the middle of things in various ways. There's parentheses, but they mean different things than they normally would if you were writing like an essay or something like that. So we're just using these symbols as pure symbols that we can inscribe any meaning into that we would like. And this can be a little bit tricky. One of the reasons this is tricky, computer science is not actually that commonly taught at the high school level, at least in the United States. So most students, when they get to college, they have a general idea of what math is, what chemistry is, what history is, what physics is, what what the arts are. But when students get to college, they often don't know what computer science is at all. There have been a number of different interesting surveys done of first-year college students, and they're not really clear what is computer science, what is engineering, what is information technology, things like that. So this style of thinking in this very symbolic way and being able to kind of reprogram your brain to think about symbols differently and to look for these kinds of underlying patterns is not something that everybody just automatically has a lot of practice in high school. So a lot of students are coming to this and they're like, whoa, my brain is not used to doing this. That's okay. It's a skill that you can learn. You just need to get some practice with it. So let's revisit a little bit about your first Java program. When we have the BlueJ videos, which will be available, you can go ahead and check those out. We'll sort of use this program and other ones in more detail. You can kind of see, like, okay, this is the start of the program, and then here's the part, this is main, there's a whole bunch of random stuff in here, and then these are the print statements we care about. We're just going to start today with this very first line. And so this part here, public class, that's kind of like a magic incantation. If you've read the Harry Potter series, you know, when they say, expecto patronum, that's just magic words. Or when they say lumos, there's like these magic incantations, open sesame, something like that. For now, I could try to explain why we put public class here, but you don't really have the context in the background for it to really make a lot of sense. So I'm just going to kind of skip over it and say, for now, there's some things like public class and down here public static void main that are basically magic incantations. They have to be there. You need to know that something needs to be there. You don't have to memorize it. You can look it up. We're not going to have exams where it's like, what goes before the name of the program. That's not an interesting exam question. You could just look it up. So you can look these things up, but you kind of do need to understand that this magic incantation has to be there as part of the structure. Now, this next part here, hello world, this is actually the name of the program. And we can name the program anything we want. Well, anything we want as long as it's what's called a valid identifier. And so this is the next concept we're going to talk about. What are the legal names we can use for the name of the program, the name of a variable, the name of a function, and so on? These have to be identifiers. So hello world, this is the name we use for the initial program. You can name your programs anything that's a legal identifier. What are the rules for an identifier? Well, it must start with a letter, an upper or lowercase letter, or an underscore. So you have to start with one of those. And then it's going to be followed by 0 or more letters, again, either upper or lower case, digits, or underscores. So you can't have any punctuation or anything like that in the name of an identifier. And by convention, the name of the program starts with an uppercase letter. Whereas the names of variables and functions, by convention, start with lowercase letters. Now, when I say by convention, I mean if you write code not following these conventions, people are going to look at it and be like, what the heck are you doing here? I mean, I know that's legal, but it just looks weird. So these are conventions that a lot of people, virtually all programmers that you come across are going to follow. So here we've got a question. So for a number of these lectures, we're going to actually embed questions in the lecture, in these video lectures. What you need to do now is go to Moodle, find the assignment. It'll be either linked from the Moodle page or linked from the Google Docs spreadsheet with the agenda of what we're doing for the term, basically from one of the versions of the online syllabus. So this first question, which of these is not a legal identifier? Go ahead and you can pause me. I won't be offended. Go ahead and pause me and then answer this question, on Moodle. And then when you're done, come back and continue playing the video. We'll go over it. So, did you come up with B? If you came up with B, you are correct. An identifier can't start with a digit. It can have a digit in it, but not as the first character. So this is okay, this is okay, this is not okay because it's trying to start with a digit, and that's not allowed. So how about this? Which of these are not legal identifiers? So again, go ahead and pause me. So, did you come up with C? If you did, you're correct. This is okay. This is okay. You can start with an underscore and end with an underscore. That's fine. This is not okay. You can't have this space in there. There's a space here. That's not allowed. Identifiers cannot have spaces contained within them. So that's something that you need to keep in mind. And I changed this example from something else to Doctor Who because I don't know what it is with Doctor Who, but apparently, you know, more and more students seem to be getting to Knox, and they're just like enormous Doctor Who fans. Meanwhile, I can't seem to get past the first season of the 2005 reboot. I've been told I should skip to the next Doctor after that and just kind of see how that goes. So maybe I'll do that one of these nights. How about these? Which of these are not legal identifiers? So, again, go to Moodle, answer it. Okay, all of the above. None of these are legal identifiers. You can't have semicolon or colons and parentheses inside a valid identifier in Java anywhere. It can't be at the end, it can't be in the middle, it can't be at the beginning. None of those are allowed, so none of these are legal identifiers. Awesome. So the next thing about our little print line example that printed out hello world, if we kind of look back at that real quick, you'll remember we had this print line, and then this is what we were printing, and we were putting it in quotes. So what's going on with the quotes? The quotes are what's called a string literal. Everything in the double quotes is going to be called a string literal. A string in computer science, it literally means a string of letters. That's the generally accepted term that we've come up with. It's maybe not a good term, but there you have it, string. So system out print line will print exactly what's in those double quotes. Anything you put in there, it's in there. The random anecdote from childhood I always use about quoting something literally. You know, when you're a little kid, you're not supposed to say bad words. You're not supposed to like drop F-bombs left and right because you're like 8. But a lot of times you'll have like a grandparent, like usually it's, you know, grandpa, who will like use foul language in front of the children. And so it's really fun when you're a little kid to repeat those things back, and then your mom's like, don't say that, and you're like, oh, I'm not saying it, I'm merely quoting literally what grandpa said. So then you get to drop F-bombs, and then your mom gets mad at your grandfather, so, you know, it's like a win-win for you, and then, you know, maybe not for everybody else. Anyway, that's the example. It's not a great example, but that's the anecdote I always give about string literal. This will print literally whatever's inside those double quotes. If what's inside the double quotes is misspelled and grammatically wrong, Java doesn't really care. It's just going to print it out as is. So sometimes you want to have a string literal that's really long, and you want to kind of fit it without having to scroll. So if that's the case, you can do what's called concatenation. So if you've got system.out.println line, this is, and then we're ending this quote and putting a plus, and then on the next line, we've got, you know, too lengthy to fit on one line. So when Java prints this out, it's just going to print it all out on one line, right? Except it's going to print this part, and then it's going to use this concatenate symbol. It's going to stick this onto the end of it. Concatenation is just a really fancy way of saying, okay, we're going to stick some things together here. Now, you note, because these are string literals, again, we've got this is. We've got to put a space here because there's no space here, right? If we left this space out, it would print this is, and then with no space, too lengthy to fit in one line, which is not grammatically correct. That's not what we wanted. So that's string concatenation. Now, of course, this is kind of a trivia point, but what's the one character that can't easily be included in a string? I put the easily in parentheses here because it can be included in a string. So what couldn't you include in a string literal? Think about that for a second. We'll go to the next slide. Obviously, a double quote, right? Because once you put a double quote, Java's going to assume that that ends the string. But occasionally you do want to print a double quote as part of a string literal, so we need to have a way to do that. And so the way you do that is you actually put a backslash in front of it. This is called an escape sequence. So you've got a double quote to start a string, he said, comma. Now we want to put a double quote inside the string. We put a backslash in front of it, then the double quote, and then whatever. And then if we want another double quote, we got to backslash that. So then this double quote actually is what ends the string literal that started here. This stuff inside it, this is known as escaped because it has this escape key, this escape sequence, the backslash in front of it. So then, of course, there's a second question. Well, Now how would you print a backslash? And the obvious answer is you put a backslash in front of that too. So if you want to print a backslash, you just have to put 2 backslashes. This doesn't come up that often. It's not something that we'll generally put on an exam or something like that because it's kind of like a trivia thing, but whenever I give this example of string literals, if I don't talk about this, it like drives some students crazy. They're like, oh my gosh, how do I print a double quote? So we went ahead and put this in here. So variables. A variable is going to store data. It's a container for some type of data. And we're going to need variables to store values in order to perform computations. If we couldn't store anything into a variable with a programming language, it would be really hard to do any computation. So Java is what is called a strongly typed language. Strongly typed means that you need to declare a type for each variable when you create it. The type is going to define the kinds of things that are allowed to be put into that variable. Now we're going to start with 3 types. We're going to have int, double, and string. Int and double, you notice these both start with a lowercase letter. String starts with an uppercase letter. These are different. Int and double are what are called primitive types. String is what's called a reference type. We'll revisit these terms for much of the rest of the term, but just for now, int and double are going to store fairly simple things. Integer can store whole numbers like -7 or 5 or 274,612. Double is going to store decimal numbers like 10.6 or 118.4372, 0.1. Things like that are going to be stored in a double. A string, as you can imagine from talking about string literals, this is a variable that will store string literals. String is what's called a reference type, as I mentioned. It needs to start with an uppercase letter. If you do string with a lowercase s, Java's not going to understand what you mean. This is a really important point to keep in mind. Java is what's called a case-sensitive language, which means that the capitalization of the letters matters. String with a capital S is not the same as string with a lowercase s. This is one of those things where you kind of need to get used to this, and people who haven't done a lot of programming, your eye just goes right over that, and you're thinking, well, string, I know what that means. But you've got to be very, very diligent about making sure that the capitalization is exactly the same, because it means something completely different if you change the capitalization. So, a little bit of background on the types. Int, these are whole numbers, but it's not completely unlimited. You get between about -2 billion up through about 2 billion. If you need larger numbers, you can store that in another type called long. The reason it's -2 billion up through 2 billion, you have about 4 billion possible numbers that you can choose. That's because integers are actually 32-bit values, and if you take 2 to the 32nd, you get about 4 billions. That's where that number 4 billion comes from. It comes from the fact that in 32 bits, yeah, you can store a lot of different integer values, but it's not unlimited. And if you need even more than -2 billion to +2 billion, there's another type called long. I don't think we'll use a lot of longs this term, but it is a thing that's available. Double will store decimal numbers. A lot of students ask, well, double, like what the heck does that mean? Double is actually short for double precision floating point number, as opposed to single precision floating point number, which is also a thing. Float basically means scientific notation. So if you think back to high school chemistry classes, 6.23 times 10 to the 27th, that's scientific notation. Right, you're taking the 6.23, the 10 times 10 to the 27th. The 10 to the 27th is going to float that decimal point either to the right, or if it were to the -27th, it would float the decimal point to the left. So that's where the term floating point comes from, and double is because it's a double precision floating point number. Now, you don't need to memorize this stuff. I'm just giving you some context and some background so that you don't spend, a half an hour wondering about the origin of the term double. And as you can probably guess, string can store some string of characters, a string literal. And a question first-year students studying computer science often have, well, string can store a string of characters. Well, how big can that string of characters be? And the answer really is as much memory as the computer has in it. A string can be a single character. You can actually have a string with 0 characters. That's a special string called the empty string or the null string. You can actually have a string with the entire text of all of Shakespeare's plays in them if you took the time to type them out or read it out of a file and put it into a single string. That's a completely legal and legitimate string. You just have to make sure you have enough memory to store all that. Oh, that's really embarrassing. There goes my phone. Oh, I'll get that in a second. Well, we're doing everything in one take, so we'll just continue on. Variables of type int. So here we've got a couple of examples. We've got, we're declaring an integer variable x, and then we're assigning it the value 7. This stuff up here with the // in front of it, these are what are called comments. I'll talk about that a little bit more when I talk about BlueJ. But these are basically notes that programmers leave for each other. They're not things that the Java language actually cares about. In fact, it just totally ignores them. So these are notes programmers leave for other programmers if you've got multiple people working on the project, or the programmers leave for themselves if you're working on something and then years later, months later, you need to work on it again. So we've got int x, we're assigning x the value 7, and then here we are doing it again. We're creating a variable, we're giving it an initial value. So here we're declaring x, we're assigning it 7. Here we're both declaring x and assigning it 7 at the same time. These two chunks of code, they basically do the same thing. Double works the same way. We've got a double, we're going to call it d, we're going to assign it 6.7. Now a double can actually convert an integer to a double. This is called a promotion. So we can say double d is assigned 6. And so this will take 6, and it'll convert it to 6.0 and make it a value. So go back onto Moodle and try this out. I think we'll restrict it to just A or B. I don't know if you'll have options C, D, and E. So should this work? Int x is assigned 6.7. So try that out. Hopefully you came up with no. This is not going to work because 6.7 is not an integer. So Java's never going to let you take a double value, 6.7, and turn that into an int without you explicitly acknowledging that you will lose information. We're going to lose track of this 0.7. An integer can store the 6 part but doesn't know any way to store the 0.7 part. Java's never going to allow that because you could lose information. There's ways the programmer can acknowledge, hey Java, I'm okay with throwing away this information, but by default Java's just never going to allow that. So how about this? Should this work? We're going to say int x, we're going to assign it 6.0. Hopefully you came up with no. Now, as humans, we can look at this and say, well, 6.0, that's the same as 6. That's true if you're a human and you're smart and can look at this, but if you're a pretty dumb computer, which computers are, they're not able to figure this out. Java's very conservative about this. It's like, look, this is a double, I see a decimal point, I'm nervous about that. Java's not going to allow that without an explicit acknowledgement from the programmer that it's going to be okay. This is called a cast. We'll see those. So here's a guess. We haven't explicitly covered this, but what do you think this is going to print? So go ahead and try this out on the Moodle. So if you came up with 6, you're correct. This int part here, this is the explicit acknowledgement by the programmer saying, hey, look, I know 6.7 is a double and that you have no way of accounting for this 0.7, but that's okay. I would like you to throw away the 0.7 and just give me the integer part 6. I should note that these casts, as they're called, always truncate. In other words, they round down. There are functions that let you round up, but you know, maybe we'll talk about them later in the term, but for now you just have to know if you're going to do casting, it's going to throw away that information. So this is going to give you 6. And finally, what does this print? So go ahead and try this out on the Moodle and then come back. Hopefully you came up with 0. This doesn't make sense to anyone who is not a programmer or computer scientist. This is because 8 and 10 are both integers. The result of dividing two integers also has to be an integer. So, well, how many times does 10 go into 8? Well, it goes in 0 times. Yeah, there's a remainder, but these are both integers. You don't care about the remainder, you just care about the quotient. 10 goes into 8, 0 times. So 0 is what's going to get put into D. It's going to print this out. We know 0, we can convert it to a double. It'll make it 0.0. Technically, it might print 0.0, but it's still going to be essentially 0, right? Because 8 divided by 10 is 0. This is kind of bizarre. I often will joke that we now live in Bizarro world, where this makes total sense once you understand the bizarre rules of types. So how could we get 0.8? This is a little bit of guesswork here, but see what you come up with on Moodle. By the way, all the Moodle review questions, like even if you get it wrong, you're still going to get credit for it. You just have to go in and do it and make sure that you understand it. So see what answer you get. Hopefully you came up with all of the above. Right, this is obviously 0.8 because this is the double, this is the double, so that's going to be 0.8. It turns out that this is also 0.8 because Java's going to look at this and say, well, this is a double, this is an int. I can't divide doubles and ints because they're different types, but I know how to convert 10 to an integer, from an integer to a double without losing information. I'm going to do that, so it's going to change this to 10.0, divide them, and you're going to get 0.8. Same thing down here, but in reverse. This is a double, this is an int. It knows how to convert ints to doubles, so it'll do that. Okay, some stuff about string variables. Basically, you know, just what you'd expect. We put the type here, we put the variable here. We got our assignment statement, and we're going to go ahead and put a string literal inside there. Now, if we print this, instead of just literally printing S1, there's no quotes here. It's going to go look up, well, what was S1 assigned? Oh, this is a string, and it's going to print this is a string. And I should note that concatenation works between string variables and string literals. So this will print this is a string and this is a string, right? Because S1 is this particular string here. So arithmetic operations, all of the arithmetic operations you learned in math, they also work in Java. Plus, minus, multiplication, division. There's actually more, but we'll start with the basic ones. So let's try this out. Int x is assigned 4 plus 3 times 6, and we're going to print out x. What is this? So I'll give you a chance to try that out in the Moodle. Hopefully... Oh, that's really embarrassing. This isn't 18. 6 times 3 is 18. Should be 22. Yeah, I'm not going to re-record this because I'm now 27 minutes and 42 seconds in. Pretend this says 22 and never speak of this again to anyone. Just pretend I never make mistakes. God, that's confusing. Anyway, 6 times 3 is 18, plus 4 is 22, right? There's an order of operations issue here. You have to do the multiplication before you do the addition, just like you learned in, math classes. So remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. There's actually a few more different arithmetic operations that we'll learn, but that's what we've got for now. And so that's what we have for your first crash course on the beginning of Java. Thank you for listening.